continue with our topic, history, philosophy, and methodology of science. I would like to thank Ojaswini for hosting us. Hope that everybody received the link to this conference. And well, we start a new theme today, which is Renaissance. Please follow the chat. Renaissance. Well, I think it is important, but you know, it depends on culture, because I would just try to understand what can be Renaissance in India, for example. Well, you had some important events in the 14th or 15th century. Maybe the empire of the great Mughals. Yes. Is it correct? Mughals. Ojaswini.
Yes. Mughals.
Yes, it's not Mughals. This
it's Mughals.
Okay. So, but it really did started somewhere in the 15th century. Yes, that they came from Tajikistan or from Middle Asia and sort of established the Sultanate of Delhi. Okay, yes, more or less. They were Muslims. Mughals, yes, or Mughals, we say. They were Muslims, so they established a Sultanate of Delhi and built a lot of mosques in India. And so I know that even one of the cities in India was called AllahAbad. Maybe it's now renamed AllahAbad, okay?
Yes, there is one city
but
named
it was from, yes, so this means this shows us very vividly the Islamic influence in India. Now it is the problem is a little bit more or less solved. AllahAbad, yes. So because Muslims were mainly left for Pakistan and Bangladesh, and the Hindus remained in Indostan Peninsula. So, well, I don't know how these events took place after the liberation, but well, just to make you understand that something can happen in the 15th century, but in Europe, these changes, sometimes very drastic, they were called Renaissance. So Renaissance means second birth, okay? Renaissance in French, so it's a French word originally, Renaissance, and naissance in French means birth. So re means repeated sort of birth. So second birth, okay? Second birth of what? Second birth of ancient Greek and Roman culture, and including ancient Greek and Roman philosophy. So, well, the word Renaissance sort of presupposes that there was a period of oblivion, sort of a period of a kind of a death. So the Middle Ages were regarded as dark ages, the ages when learning was sort of obliterated or forgotten. So this is, otherwise Renaissance doesn't make sense. If there was a continuous progress through the Middle Ages, the development, so then why speak about Renaissance? Then we can speak about just well, step-by-step progress. So Renaissance means that something negative happened during the Middle Ages. What well, the the philosophers of the historians of philosophy like Hegel accuse Middle Ages of obscurantism, and according to Hegel, the world spirit was as if sleeping during the Middle Ages. So you see, and then he sort of during Renaissance he was reawakened from sleep. And the same, well, when I studied philosophy and also history of culture during the Soviet period, we made much of the citation from Engels about the Renaissance. Engels, well, Engels, maybe you know, you have forgotten him, but for us it was like a third person of the Marxist trinity. Oh no, second person, Marx, Engels, and Lenin. So this was the trinity, okay? So the portrait of Engels was very much familiar to me and to everybody, especially also Marx, but there were sort of undivided Marx and Engels. So Engels wrote in his Dialectic of Nature, his work, Dialectic of Nature, by the way, very important for our theme, history, philosophy, and methodology of science, Dialectic of Nature. He wrote these words about the Renaissance. The Renaissance was the greatest progressive revolution that mankind has ever experienced. Progressive revolution. It called for giants and produced giants, giants in the power of thought, passion, and character, universality and learning. We had to memorize it by heart, okay? This was because it was so very important that our teacher of English literature in Soviet school asked us to learn it by heart, this citation. So when we started Renaissance, well, of course, we studied English literature, we studied English Renaissance, I mean Shakespeare, you understand. But still Shakespeare was sort of ushered or sort of prefaced by this citation from Engels. So this was very important. The greatest progressive revolution. And the giants. Who were the giants? Well, we can think that these giants were Leonardo da Vinci, Well, maybe you all can also add to this like short list of giants. Leonardo da Vinci, Michelangelo, Michelangelo. Well, we can add Copernicus if we just need a scientific figure. Copernicus. And we can add also Cardano among the scientists. Well, about Leonardo da Vinci, I will say a few words because he was a polymath. He was not only a painter, an artist, he was also a scientist and an engineer. He even in his private papers or diaries, which were rediscovered in the end of the 19th century, now there could be found very interesting information about the books he had read and about his ideas. Well, he considered, for example, the moon, he considered Earth akin to celestial bodies. And being an artist, he understood very well that if we sort of look at the Earth from the moon, we will see just the Earth will look like a moon, so it will have phases, and you understand. So this is symmetrical. So there, for us, the moon seems to be a celestial body because it is luminous. It borrows its light from the sun, but it appears luminous in the sky. That's why Aristotle considered it to be made of ether, or the fifth essence. You remember we spoke about sublunar world, and I asked maybe if there are some people who know Arabic language, whether in Arabic there exists this adjective sublunar. Maybe Salman Sayed can help me. Do you know Arabic language?
I know.
Oh, okay. So can you find in the Arabic language an adjective which corresponds to sublunar?
Sublunar. Okay.
Yeah, please try, because I had in another group, I had a student from Sudan who knows Arabic very well, and he wrote me in Arabic this adjective sublunar. So I think that perhaps it is a common knowledge. Well, I insist that this word exists in Arabic language because Arab commentators to Aristotle, like Ibn Rushd, they used this word, you understand, to express some Aristotelian idea, the idea of dichotomy of between four elements, or sublunar and heavenly world. You understand? Dichotomy.
You mean the translation of this word, sir?
Yes, sublunar in Arabic.
Qamar, under the moon.
Yes.
Under the moon, yes.
Under the moon, yes. But how it sounds in Arabic?
تحت القمر.
Okay. Very good.
القمر.
Okay. So you have this expression, yes, in Arabic language.
Yes.
Just one word, yes.
Yes.
Okay. Very good. So that means that there was a like dichotomy between the sublunar and heavenly, and well, it was a little bit hampering the progress of science, because in reality it is not so. We know that the moon is made out of the same elements as the Earth. Well, not exactly the same, but those elements are found in the Mendeleev table. Okay, so there's nothing special about the matter out of which moon is built, or stuff. So there's nothing special about the lunar stuff. Okay, but for Aristotle, it was he sort of imagined that the moon is built out of completely other element, which he called ether. Okay, so Leonardo da Vinci suggested a mental experiment. If you sort of mentally or in your imagination get to the moon and look from the moon on our Earth, so what will you see? And he said that this Earth, which is so familiar for us, from the point of view of the observer who is placed on the moon, will look like a moon itself as we see it from Earth. Okay, so it will be like some sphere, well, partly or fully illuminated by the light of the sun. Okay, so he said, well, maybe this dichotomy exists only in our imagination. Maybe the moon is the same as the Earth, but only the difference is that it is far away and we look at it from a large distance, so we cannot observe any roughness of its surface. Okay, so this was the ideas that Leonardo da Vinci expressed privately in his diaries. He never published books, so his ideas remained his personal ones, and perhaps didn't have a large influence. But you know, these ideas of Leonardo da Vinci were not only his own. He was born in I think 1452 and died in 1519. So this is the period when young Copernicus visited Italy and studied there. And he wrote also, while staying in Italy, a little work which remained in a manuscript. It was not published, which is called in Latin, well, in Latin it's Commentariolus, or in English it's a little commentary, where he expressed at first time his ideas about heliocentrism. So there is a connection between those opinions which were expressed by Leonardo da Vinci and the opinions of young Copernicus. Then Copernicus returned from, well, he was born in, he was a little bit younger than Leonardo da Vinci. He was born in 1473 and he died in 1543. But so he was quite a young man when he visited Italy. And that time, I think Leonardo da Vinci was in his 50s. I'm not sure that they met personally, but they may have common acquaintances. So when Copernicus arrived from Italy to Poland, to his native city Frombork, where is now a museum devoted to Copernicus. So he continued the investigations and continued to sort of work on this heliocentric system. And not long before his death, exactly in the year of his death, he published a book which was called on the revolutions of the heavenly bodies, on the revolutions of on the rotation maybe, but in Latin, it was written in Latin, revolutions. Well, you know what is revolution. Well, the first meaning of this word is rotation, on the revolutions of the heavenly bodies. But then revolution got another meaning, which is upheaval or overthrow or coup attempt or overthrow of a government or political system. Well, of course, in the times of Copernicus, there was no such meaning of the revolution as something like change of paradigms, okay, of the heavenly spheres, orbs, heavenly orbs. De Revolutionibus Orbium Celestium, that it was called in Latin, and it was written in Latin. Leonardo da Vinci didn't know Latin. Leonardo da Vinci wrote in Italian because he didn't receive proper education. So he was considered to be well, this was his deficiency, that he didn't know Latin and he never wrote in Latin, okay? So, but Latin was in this period the language of the educated. So Copernicus wrote both his Commentariolus and the book on the revolutions of the heavenly orbs in Latin in order to be understood. Of course, he knew Polish and he knew perhaps German because he lived on the border in the town which was belonged to formerly to Germans, then to Poles. So it was like disputed territory. So there were a lot of Germans there, and Germans sometimes wanted to recapture this city. So he knew I think some of a little bit of German, and of course he knew his native language, Polish, but he decided to write neither in German nor in Polish, but in Latin. So he wrote his book in Latin, and it had certain success. So people paid attention to it. But this attention was kind of limited. There was a young student from Wittenberg University called Rheticus, who was a Protestant. At that time, there already appeared Protestantism, new variant of Christianity, in 1517. Martin Luther started sort of a religious revolution or reformation in exactly Wittenberg University, from which Rheticus graduated. So Rheticus was a Protestant, Copernicus was a Catholic, but this passion for astronomy united them both, so they worked together for 2 years, and then Rheticus, because he was younger and he was more enthusiastic, so he sort of asked permission from Copernicus to publish his work in Nuremberg. Well, Copernicus was a little bit afraid, and he reluctantly gave his permission to publish this work. But he couldn't like fight with the temptation to see his his ideas published. So he agreed at last, and the work was published in 1543 in Nuremberg. So at that time there were already publishing houses in Europe, Nuremberg. So you see, it's greatly helped the dissemination of knowledge. So Renaissance was also possible because of the invention of the printing press. Okay, this is also not to be underestimated. So in Nuremberg, the book of Copernicus was published. Well, of course, it was revolutionary in its contents, so that we can say that it presented totally new idea of the universe. With Aristotle, as we started our lecture with this sublunar and its possible translation into Arabic, well, also in Russian we say подлунный if we are speaking in Russia. Well, now of course подлунный seems in Russian is obsolete, but in the 19th century it was used by poets. For example, by our poet Pushkin, who wrote the verses and I would be glorious until in the sublunar world will live just on one single poet. So this is a sublunar world with Pushkin, it's synonymous to Earth. Okay, so living in the sublunar world means or be found in the sublunar world, it means to be found on Earth. On Earth can be found a poet, and if there is one just poet on Earth or in sublunar world, then the name of Pushkin will remain glorious. So this poet will appreciate the contribution of Pushkin to world poetry. Well, this is like a international of poets, you understand. Poets like each other, understand each other, well, so this sublunar is also Russian word. But returning to Copernicus, so with Copernicus we have a totally new picture. There is no sublunar world in Copernican system because the Earth is one of the heavenly bodies now. So everything is a kind of heavenly, okay? So there's no, how to say, great difference between the Earth and other planets. So Earth is one of the planets. So it seems that its nature should be akin to the nature of all other planets, okay? This seems logical. So there's a dichotomy of which Aristotle spoke is sort of evaporated, okay? It did not exist anymore, okay? So this is the major contribution of Copernicus to the history of world ideas. So, but because in all the universities at that time, there were almost 100 universities in Europe. In the north, the most northern university was a University of Uppsala in Sweden. In the south, we had a university in Seville, in Spain. So from Seville to Uppsala and from Nantes to Krakow, there were a lot of, or Vilno, there were a lot of universities in Europe. Only Russia had no universities at that time, and perhaps the Ottoman Empire also. Well, but in Europe, this was a common, how to say, paradigm of education, educational paradigm, university education. So, but in all these 100 universities or so, there was taught Aristotelian cosmology. So people were obliged to learn by heart 4 elements of Aristotle, 4 elements of the sublunar world, and they were told that the moon and what is upper than the moon, or like farther than the moon, other celestial bodies like the sun and so on, they were made out of ether, the principally the 5th element, okay? So that was when you are taught something from the cathedra, okay, by the professor, so you cannot withstand his authority, okay? I remember when I was studying in Moscow University, on the 2nd floor of physical department of Moscow University, there was a gallery with portraits of famous Russian scientists, or contemporary academicians like Landau, Ginsburg, Landsberg, also Pontecorva, Artsimovich, Khokhlov, Velikhov, and other academicians, so prominent physicists. And all of them taught this more or less the same paradigm. So you couldn't sort of say that I'm more wise than all those esteemed academicians, okay? So it takes time to understand that all those professors of medieval universities or Renaissance universities who taught Aristotelian cosmology were wrong, and only Leonardo da Vinci and Copernicus and Rheticus and some other queer people were right, and that the Earth was one of the planets and the moon was not different from the Earth, okay? So this was a brand new idea, and it had it needed time that for this idea to be accepted by professors of all the universities. Now, of course, if you study in every place, starting from Africa and ending with Australia, so no university will teach Aristotelian cosmology. So everywhere when the question will arise about the structure of the solar system, you will be taught a heliocentric system or Copernican cosmology. I think everywhere, in Sohaj, for example, in Egypt. Are there anybody from Egypt here? Egypt. Do you know the Sohaj University in Egypt? No.
No, sir.
Sohaj University in Egypt. There's a new university, and there were a lot of people from this university. Last year, I taught them history and philosophy of science. They were postgraduates from Egypt. Now there's no people from Egypt here, but maybe there are some people from India. So there's a university, I think, in many Indian states, in New Delhi or in cities. In New Delhi, there's of course a university, perhaps in Calcutta, yes, maybe in Mumbai. Who knows the Indian universities? Ojaswini.
Yes, sir. There are many universities. Which one
Yes,
you're talking about?
in your Rajasthan, you are from what state?
New
Rajasthan?
Delhi.
Ah,
New Delhi.
you are from New Delhi. You are
Yeah.
a metropolitan citizen, so you live in the capital, like me. I'm a Muslimite. Okay, so in New Delhi, there's certainly a university, okay, or maybe many universities.
Yes, sir.
And
Many.
you will not find a university when they will teach you Ptolemaic cosmology or Aristotelian cosmology. So they are sort of, you understand, they are outdated. So nobody will teach them. Only they will be remembered in the course like mine, history, philosophy, and methodology of science. So this, you understand. But at that time, the situation was very different. So the universities of that time taught geocentric Aristotelian cosmology. So on the example of the destiny of Copernican hypothesis, we can see how inert, you understand, inert or inertial, yes? Can we use this inert like in meaning of massive, inertial, like motionless, okay? So the mentality of mankind is addicted to a certain like formulas or ideas which and if everyone accepts the same idea, then it is evaluated as consensus, consensus of consensus, and you cannot stand against the consensus of all the people. So Copernicus was bold enough to challenge this consensus, okay? So this is why his book on the revolution of the heavenly orbs was named by philosopher of science, American philosopher of science, Thomas Kuhn, the Copernican Revolution. You understand, it's a play of words. Thomas Kuhn wrote the book, The Copernican Revolution, in 1957. So this is a philosophy of science, the Copernican Revolution. Okay, so you see the Copernican Revolution. So now revolution becomes like a play of words, because Copernicus himself wrote the book on the revolutions of the heavenly orbs. So Copernicus used the word revolution in a sense of rotation. But Thomas Kuhn, while writing the book, The Copernican Revolution, he used this word revolution in quite a different sense, in which it is used in politics when we speak about the French Revolution or the Russian Revolution, so in political meaning. And well, but of course there was nothing political. It is scientific revolution. So revolutions happen also in science. And the first such great revolution was, according to Thomas Kuhn, the Copernican Revolution. 5 years later, Thomas Kuhn wrote another book, The Structure of scientific revolution, which I greatly recommend you. Revolutions. So now to the Copernican revolutions were added other revolutions. For example, Einsteinian revolution, the revolution of the which was caused by the appearance of the special and then general theory of relativity. Also, quantum mechanics led to a revolution in our understanding of elementary particles and so on. Now, Ojaswini, you will resume the conference. Ojaswini, let's continue. How is the temperature in New Delhi? Is it hot now in New Delhi?
Sir, it's
But
winter, but
you are in Dolgoprudny, yes?
yeah, in comparison to Moscow,
Yeah, you are in Dolgoprudny, I know.
yeah, I am here.
But maybe some of your relatives are still in New Delhi.
Yes,
You
sir.
correspond?
Family is there
Yes.
only. Yeah.
What do they say about the temperature in New Delhi?
According to
It-
them, it's cold right now, but it's not cold in comparison to Moscow, obviously. For them,
Okay,
15
so
degrees is also very cold, but 15 is a summer time for me here.
I see. But it's warmer in New Delhi than in Moscow, okay?
Yes, of course.
Well, okay, so just for relaxation, because I hope you feel very well, and because now it's much colder than it was a week before, so I was afraid that you will leave Moscow for New Delhi because of the cold, but you seem to be very, how to say, fearless, yes? Or just
Yes, sir. I've turned myself into a Moscowite now, so no
Okay,
problem.
very good, very good. So I hope you will survive. Okay, now we will continue with the Copernican Revolution. So now we have only one man. It's Rheticus, the pupil of Copernicus, who helped to publish his book, who was the main promoter of this heliocentric system. Other people were a little bit skeptical. I mentioned to you the name of Cardano. Cardano, let's return again to this name. Cardano was a great mathematician. He invented the formula for cubic equations, and he also gave a contribution to the theory of probability theory. He wrote a book about the playing dice. Dice, which is like chance, or this little cube. You understand? Okay, dice.
Yes, sir. It's a game.
Yeah. Okay, that's Cardano. Also, he was a physician because he received medical education in one of European universities. So he considered himself to be one of the best physicians of his age. Well, he was a little bit boastful. I mean, Cardano. His temperament was a little bit, I would say, not very well balanced. He wrote a book, autobiography, so you can read it in English or in Italian, well, even in Russian. So if you read it in English, you will find some curious facts which he tells about himself. He is very outspoken. So, but well, Cardano is very well remembered. Cardon, for example. But still, he had some deficiencies because he was an astrologist and he didn't take Copernicus seriously. And he said that the moon is a perfect body and has no gravity. Okay, this the citation from one of his works. So he considered that moon has no gravity. What does it mean? What is gravity? Gravity, according to Aristotle, is the property of sublunar elements like water and earth, they are considered by Aristotle heavy, and air and fire are considered light. You understand? Heavy and light, okay? Light not in the meaning of light, but light has another meaning, is not heavy, okay? You understand this? Not heavy.
Yes,
Not,
sir.
yes, this word has many meanings, okay? So light, of course, the first meaning is light, the sunlight, but also light, it means not heavy. So light and heavy. So earth and water are heavy elements, and air and fire are light elements. So, and Ethereal bodies like the moon, according to Aristotle, they do not have they have neither gravity nor lightness. Okay, this means Cardano was in this respect a firm Aristotelian. When Cardano wrote this phrase that the moon has no gravity, he was just repeating the common opinion of the learned people of his time. Okay, so he was like one of those maybe thousands of professors or of educated people who firmly believed that Aristotle was right, in spite of the fact that Cardano was in certain respects very inventive and ahead of his age. Well, there was another educated man, Francesco Sizzi, a humanist from Venice. Francesco, or maybe from Florence. Francesco, I don't know, yeah, just look, Sizzi, an Italian also, like Cardano. And he objected even when there appeared a book by Galileo, the Starry Messenger, where Galileo informed the public that he found the 4 moons of Jupiter. Francesco Sizzi still objected to that fact established by Galileo by saying that there are only 7 heavenly bodies, as there are 7 metals and 7 holes in man's head. Well, first of all, this analogy between 7 heavenly bodies and 7 metals. So sun corresponds to gold, moon corresponds to silver, Mercury corresponds to mercury, okay, or quicksilver, and then Venus corresponds to copper, Mars corresponds to iron, Jupiter corresponds to tin, and Saturn corresponds to lead. So 7 celestial bodies and 7 metals. What you see here, Earth is lacking because Earth is not considered in this analogy the celestial body, okay? So there is no metal that corresponds to Earth, okay? Because this is a typically geocentric attitude. Then the second, which Sizzi added from himself, that in the microcosm or man, in his head, there are 7 holes, okay? Like 2 eyes, 2 nostrils, 1 mouth, and 2 ears. All in all, 7, okay? So 7 holes in man's head, 7 metals on earth, and 7 heavenly bodies. So there's a kind of a symmetry, okay? So people esteemed very much this symmetry and didn't want to part with it. So in this way, the world seemed very cozy and familiar. Also, we mentioned that Cardano was a medical man. At that time, medical men believed that the disease is, the health is the equilibrium of four fluids, and the disease is the excess of one fluids over others. There were four fluids in man's body. So this phlegm, blood, yellow bile, and black bile. All in all, four fluids. And of course, there was a temptation to sort of find like analogy between four fluids and four Aristotelian elements. So phlegm corresponded to water, blood to air, yellow bile to fire, and black bile to earth. So four elements of Aristotle were somehow connected with four fluids in human organism, and seven metals were connected with seven heavenly bodies. So everything was connected, everything was symmetrical, and you see, everybody liked it very much. So new ideas were like disturbing, and they shattered this symmetry, this equilibrium for which people got accustomed. Like we got accustomed to 6 quarks and 6 leptons and 6 particles which carry the interactions, okay? So quark model it's called, yes? Or we are accustomed to, say, Big Bang cosmology, or we are accustomed to Mendeleev's table. So if somebody will question these things which we consider basic, people will just shrug their shoulders and say, well, what is that? This is a paradigm, you see, according to Thomas Kuhn, this is a paradigm. Paradigm is in Greek, it's an example. So this is like, well, now it is, I think this word is widely used, yes? Ojaswini, yes? Paradigm. Do you know this?
Can you repeat it?
Paradigm, I wrote it in chat. Paradigm.
I have no idea about that, sir.
So if you don't know this word, you're not familiar with this word, this is, please repeat it, because it is, or find it, because it is a very important notion for our subject, history, philosophy, and methodology of science. Paradigm. It's pronounced paradigm. It's written in this way, like I wrote it in chat. You, of course, can find it in every dictionary, online dictionary, or just, well.
I know the meaning, sir. I didn't know how to relate it with philosophy, but I'll research it.
You didn't know?
I know the meaning of the paradigm, but I didn't know how to relate it with philosophy.
Okay. So you know this word. When it is written, you recognize it. That's good.
Yes, sir.
So only this, for me, it was also a problem to pronounce it correctly, but I listened to some courses, English courses of history and philosophy of science, just to get accustomed to pronunciation. And so I got it, how it is pronounced by Americans, say, or English professors of philosophy of science. So this, they pronounce it paradigm, okay, paradigm. This is, in Russian, we say paradigma. This is just a little bit different, yes, pronunciation. Okay, so this was a paradigm, and Cardano was just accepting or sharing this common paradigm. He didn't want to be a revolutionary in this respect, although he was, of course, very talented and innovative in mathematics or in probability theory, or maybe even in medicine. So you see, the prospects of accepting Copernican theory by everybody seemed very dim and uncertain. But there were some people in Italy also who looked benignly on the Copernican system, and I can mention one example. Gian Bautista Benedetti, or Giovanni Battista Benedetti. Well, if you look in the Wikipedia, you will find an article about Gian Battista Benedetti, although, of course, as far as my experience of a teacher, students are not acquainted with this name. Well, Gian Battista Benedetti wrote a book on diverse questions of physics and mathematics. And in one of the chapters of this book, he repeated this, idea, which we find already in Leonardo da Vinci, that if we look on our Earth from some heavenly bodies, our Earth will look like a tiny star or a tiny planet, okay? Or can be even not seen at all, okay? If we look at it from the distant star, for example, well, from the polar star, we can, perhaps we will not even see our Earth. So this, this is the argument against Aristotelian idea that we cannot find any changes in heavenly bodies. So Gian Battista Benedetti expressed this thought that if we look at our Earth from distant planet or distant star, we will not find any changes on Earth because we will barely see the Earth itself. And if we see it as a tiny star, of course, we can say there are no changes. Although, if we live on Earth, we see that there's a lot of changes here. For example, COVID epidemics or Zoom conference or birth and death of people or wars or new civilizations and a lot of things to be observed. But if you look at our planet from distant star, you will not see anything. You will even doubt whether our Earth is inhabited or not, okay? You understand the problem? So the problem is only in that we are the inhabitants of the Earth and the stars are far away from us. That's why that's how Benedict explained this erroneous opinion of Aristotle that there is a difference between stars and our Earth. So on our Earth, we see a lot of motion and a lot of changes. And in the domain of the sky, we don't see any changes. So the sky remains just the same as it is. No changes can be found there. This is the point of view of Benedetti. Also, one Danish astronomer Tycho Brahe was led into some doubts about Aristotelian cosmology. Brahe, I think Brahe, yes. Well, I think it's like he's spelled like that, Tycho Brahe. Well, he was a Danish astronomer, and he was not a theoretical man. He was not a philosopher. He just observed the sky. And in 1572, while observing the sky, he noticed a new star, which was seen for approximately 7 months and then disappeared. Well, at first it was very, very bright. And then its brightness sort of decreased. And then after 7 months, it disappeared from the sky. Well, now we see that Tycho Brahe watched the burst of supernova star. Supernova, you understand? Supernova. Supernova, or maybe in one, even in one word. Supernova star. Okay. So this is happens, this sudden increase in luminescence. It happens when there is some catastrophic process going within the star. The star condenses from how to say red giant to white dwarf. And a lot of energy is emitted in outer space. So what we seen in particular is the line of cobalt. When cobalt changes into iron, so there's this transition has a strong line, spectral line in optical, like in optical domain. So that's why we see it. And this cobalt has like a lifespan of about 7 months, and then this radioactive cobalt sort of how to say changes. That this is a nuclear reaction. It changes into iron. So, but these 7 months correspond to this period during which Tycho Brahe observed this new star. Of course, Tycho Brahe didn't know anything about cobalt, about nuclear reactions, about sort of star evolution, but he was a good observer. And here is one example that something really changes in the world of stars. So Aristotle is not right. We can say Aristotelian idea of inchangeability of this heavenly region is falsified. Falsified. You know what is to falsify. This is a also important concept of history and philosophy of science. What is to falsify, Ojaswini? You understand what is to falsify? You don't listen to me. Who is listening? Maybe nobody.
So,
Yes, I'm listening, sir.
You know what is the meaning of this word falsify?
Yes, sir.
Okay, so falsify is to prove false, to prove that something is false. For example, you can prove that I am speaking, giving you false information. You just Google my what I write in chat and find some mistakes. For example, non Gian Bautista, but Gian Bautista, for example. You can say, I misspelled the name of Benedetti. And this will be equivalent of falsifying, to falsify, to prove false. So what did Tycho Brahe do with his observations? His observations falsified the thesis of Aristotle that nothing changes in heavenly world. Changes are only can happen in sublunar world. In heavenly world, no changes can happen. But he saw this star. So what could be objection that perhaps they say that Tycho Brahe noticed atmospheric phenomenon and took it for a new star, okay? But now we know that it is not so. And Tycho Brahe very well understood that this is not an atmospheric phenomenon. This happens in the domain of the stars, because he knew already what does it mean a parallax. So if there's some atmospheric phenomenon, the parallax would change. So if you observe it from a different place, the angle will be changed, but nothing of the kind happened. Okay, so Tycho Brahe wrote a book on these observations of the new star. So it led him later to how to say, embrace how do you say compromise system, something in between Copernican and Ptolemaic. So according to Tycho Brahe, all these planets move around the sun, but the sun with all the planets move around the earth. Okay, so this is a kind of a compromise. But his pupil Johann Kepler, a German, was a staunch Copernican. Kepler. In Johann Kepler, in 1596, wrote a book which was called Cosmographic Mystery, or Mysterium Cosmographicum. So in this book, he in the preface to this book, he wrote that he embraces Copernican system. So there appeared a second person who was, or the third, if we include Benedict, so Rheticus, Benedict, Kepler, and also there appeared a scientist in England, William Gilbert, who wrote a book on magnet. On magnet. This book appeared in 1600. So in this book, William Gilbert also pronounced himself to be the adherent of the Copernican system. So, you know, little by little, very prominent scientists in Europe became more and more favorable to Copernican system. One of them was famous Giordano Bruno. You know Bruno, maybe from your classes in history of Europe, or just Winnie, or you hear it for the first time, Giordano Bruno.
We studied it in the general knowledge, sir.
Yes, because he was burnt at the stake by Roman Inquisition, yes? So he was like a martyr of science, okay? So Giordano Bruno was also an enthusiast of Copernican system. So he was burnt at the stake in the year 1600, in the year in which William Gilbert's book on magnet appeared in London. So at that time, Giordano Bruno was burnt by the Inquisition for heresy. He was accused of heresy and burnt in Rome, on the a square of flowers, Campo dei Fiori. Fiori. This means flowers. So in the 19th century, there was a monument built on this square in honor of Giordano Bruno. But during the reign of Mussolini, this monument was demolished because the Catholic Church objected against the existence of such monument in Rome. Okay, so now I don't know whether it is reintroduced or not. So we have to visit this Campo dei Fiori or see it in GPS coordinates. Just street view, take the street view and see whether the monument is there or not. I didn't how to say, didn't certify this information. Okay, so you can do it yourself. But now we have a lot of people: Gilbert, Bruno, Kepler, Benedetti, Tycho Brahe, well, to some extent, and now also Rheticus. So the enthusiasts of Copernican system the number of those who accepted Copernican views starts to grow. But the most important of them was Galileo. Well, at first, if we take Galileo was a professor of mathematics in Pisa, a small Italian city, which is famous for its falling tower, or the tower which is not vertical exactly, okay? Pisa Tower, yes? Pisan, maybe, tower. Well, you can also look it in Google Images. So this University of Pisa was not very prominent, but still it was the only university in the Florentine Duchy or Tuscany. So Florence was a big city, but the University of Florence was very poor in comparison with the University of Pisa. So many people from Florence went to Pisa to get their education there. So Galileo, when teaching in Pisa, was the adherent of of Aristotelian system, and had some objections against Copernican system. But little by little, while reading Kepler, Leaning Tower of Pisa, yes, exactly, thank you, Ojaswini, yes, it's exactly there. Maybe this is very spectacular, okay? So little by little, the position of Galileo was changed. So, and especially changed radically when in 1610 he observed with the telescope the moon, and found some, like he wrote, mountains on moon, and also he thought that he found some seas, or lakes on the moon. So he said that that his observations of the lunar surface proved that the lunar surface is rough, not ideally polished like it was claimed by Aristotelians. So it was one argument. And the second one, that he found 4 satellites of Jupiter. So this idea of a symmetry between 7 metals and 7 heavenly bodies somehow disappeared, because 4 additional metals were needed in order to reestablish this harmony. Well, and everybody understood that something is lacking in this like symmetry, which alchemists were proud of and made much of, this symmetry between metals and heavenly bodies. Well, astrology also was now a risky affair, because according to Copernicus, the real motions of the planets are not as they seem from the Earth, okay? Well, something was changing. The book which Galileo wrote in 1610 and published in Venice in Latin was called Starry Messenger. Starry Messenger. Well, so of course, after these new confirmations of Copernican system, Galileo became a proponent of Copernicanism. And he even wrote letters to the duchess of, to the woman who was the ruling at that time, or the wife of the Duke of Florence of Tuscany. He wrote to her letters explaining his view on the motion of the earth. And well, the main idea or the main objection was that the Holy Bible, or just the Bible, sort of seems to contradict the idea of the motion of the earth. Because in the Bible, especially in Psalm 18, there is written that sun is compared with a giant that comes out of his tabernacle in order to run its course across the sky. So you see, so what can we now do with this psalm? Of course, we can, explain it allegorically. We can say that, well, according to the author of the psalm, he didn't know the exact Copernican system, heliocentric system, so he was ignorant of astronomy. That's why he wrote in such a way, as if the sun moves and the earth is immobile. But you know, there were many people who made comments on this psalm, like St. Augustine, St. Basil, and other very important church figures who were called church fathers. So there was a certain consensus of the church fathers in interpreting this psalm. So Galileo risked to be accused of heresy and share the destiny of Giordano Bruno. So he was a little bit afraid. So in February 1616, he was summoned to Rome and asked to to swear that he will not defend Copernican system, okay? And he wrote, he subscribed under this decree that he promises not to promote Copernican doctrine. But all drastically changed 16 years later in 1632, when Galileo published a book, Dialogue on Two World Systems, Copernican and Ptolemaic. And the church found this book very well suspected of heresy. And so after the publication of this book, Galileo had many unpleasant moments. He was again summoned to Rome and was accused of heresy, and he had to abjure, abjure, or just say that he has nothing to do with Copernican system, and he promised again not to defend Copernican system. Well, this saved his life, and he could continue to study, to make science, and he wrote another book, The Dialogue on Two Sciences. And also he had some pupils. Among them was Torricelli, who later, after the death of Galileo, made a very important experiment proving the existence of atmospheric pressure. So science continued despite this opposition from the church. Italian science and science in other countries, especially in Protestant countries where the authority of the Catholic Church was zero. So everything continues. So this is a happy end, yes, Ojaswini and others. So this happy end, okay? We will continue next Tuesday. I will just make some conclusions. Today I had no time, okay? So thank you for hosting us, Ojaswini, and enjoy our weather in Dolgoprudny.
Yes.